Algebra 2. We are in Chapter 5, Section 4 right now. And like I always say, please make sure we work through the warm-up because it's reminding us of certain things we need to know before we go through the lesson. Okay, first of all, factor the expression. Okay, that means we're taking out the common, the largest thing common between both terms. This is a term and that's a term. Okay, what's the biggest thing common between both of them? Looks like the numbers, I have a 5, and then the variables, I have an x. If I take a 5x out of the first term, I get a 2 left over. Take a 5x out of the second term, I get an x left over. So that right there is factored. Okay, here's a trinomial. That means I need two things that multiply to get negative 48 and add to get negative 2. I know 6 times 8 is 48. It's a negative 48, so I can make this a negative. And if I add those two, I get a negative 2. So x plus 6 and x minus 8 is factored. Okay, here I have a trinomial, a little bit harder to factor. We had a form that when we had a cubed minus b cubed, we would have a minus b times a squared plus ab plus b squared. Okay, we're going way back, right? Therefore, I have x minus 5, x squared plus 5x plus 25 is factored. And what is the volume and surface area of a cardboard shipping carton that measures 15 by 18 by 20? The volume will be all those things multiplied together. Let me grab my calculator. I don't have that ready. So I'm doing 15 times 18 times 20, which is 5,400 inches cubed. That's the volume. And then surface area is just, goodness, if we've got a three-dimensional figure, sort of hard to draw, I need the area of this times 2, so 15 times 18 times 2. The area of this times 2, I don't know, 15 times 20 times 2, and the area of this times 2, which is 18 times 20 times 2. Let's go ahead and try that. I'm going to pause. I guess I should say the reason I'm doing times 2 is because for this one I've got this front face and then I have a back face that matches it. For this top, I also have a bottom that matches it. And for this side, I also have the other side that matches it. So if we do all that multiplication, you get 930 times 2, which is 1860 inches squared for the surface area. All right, into the normal lesson. A rational expression is in simplified form if its numerator and denominator have no common factors other than plus or minus 1. To simplify a rational expression, apply the following property. Okay, this is the simplifying rational expressions. Remember, a rational expression is anything with a bunch of stuff on a numerator and a bunch of stuff on a denominator, with addition, subtraction, multiplication, whatever it is. So we're going to say let A, B, and C be expressions with B is not equal to 0 and C is not equal to 0. And the following properties apply. When you have AC over BC, I can cancel out the C's and I'm left with A over B. That's divide out the common factor C. Examples would be 15 over 65. I can break 15 into 3 times 5. I can break 65 into 13 times 5. Cancel out the 5's. I'm left with 3 over 13. Okay, another example. I factor out a numerator. I completely factor the numerator. I completely factor the denominator. I can see that x plus 3 over x plus 3 cancels out, and I'm left with 4 over x minus 5. Okay, divide out the common factor. Okay, this is simplified form if, when you look at your answers, there's no other way to simplify it. Also, continuing on, simplifying a rational expression usually requires 2 steps. First, factor the numerator. and the denominator. Then divide out any factors that are common to both numerator and denominator. Here's the example. I have x squared plus 7x. I factor that out into x plus 7x. X squared factors to x plus x. I can cancel out the x's, and I'm left with x plus 7 over x. Notice you can divide out common factors in the second expression above. However, you cannot divide out like terms in the third expression. Here, I'm as simplified as I can get. Where we are going to get incorrect answers is when people go like this and say my answer is 7. That's not correct. Okay, I can only, this numerator is a variable plus a variable. I cannot separate them out. I cannot go x over x, 7. Okay, because there is a plus in between the x and the 7, they're connected together. You cannot separate them. I cannot go like that. Okay, that's not a valid move in math. Here is the most simple form. You're done. All right, so I just told you have to factor the numerator and the denominator, and then cancel things out. So that denominator is an a squared minus b squared form, which gives us a plus b and a minus b. Okay, the numerator is, I've got two things that multiply to negative 15 and add to negative 2. I think 3 times 5. If that's a negative 5 and I add those together, I get negative 2. So x plus 3 and x minus 5. Okay, here's a little clue. When I'm factoring things, I know that one of my numerators is going to be x plus 3 or x minus 3. Okay, this is algebra class where things are going to normally work out. So when you see a numerator and a denominator, you know you're going to have things that cancel. And you know you're going to have things that don't cancel. So you know what you're left with. Okay, that right there is your final answer. Moving on, efficiency. Manufacturers often package their products in a way that uses the least amount of packaging material. One measure of the efficiency of a package is the ratio of its surface area to its volume. Okay, ratio of surface area to volume. The smaller the ratio, the more efficient the packaging. A company makes a tin to hold flavored popcorn. The tin is a rectangular prism with a square base. If the company is designing a new tin with the same base and twice the height of the old tin, find the surface area and the volume of each tin. Calculate the ratio of surface area to volume for each tin. What do the ratios tell you about the efficiencies of the two tins? All right, I first feel like I need to draw a picture of this. Okay, we have the old popcorn tin, right? Where this is S times H. And the new popcorn tin, where the height has increased by 2. Oh gosh. Yeah, I'm gonna start over. Sorry about that. Let's try this again. There we go. That's not right. There we go. Oh, for goodness sakes, I'm doing awesome. I love drawing boxes. It's true, I really do. I don't know why I'm having such difficulty. So this is S times 2H. So the old box, I have the surface area is 2 times S squared plus so that's the bottom and the top. And then we have the 4 sides, 4 times S times H, right? So the new one, for the surface area, I have 2 times S squared, which is the bottom and the top, plus, now the height here is doubled. So we want 4 times S times 2h. So the surface area is 2s squared plus 8sh. Now my volume is going to be base length times width times height. So s times h, or s squared times h. And the new one, I've got base length times width times height, which is going to be 2s squared h. Now we want the ratio of surface area to volume, which is what we've been talking about. 2s squared plus 4sh over s squared h. And I can actually simplify this. So I factor out the numerator. I can factor out a 2s, and I get an s plus 2h left over. S times h. I can cancel out the things that are common, which is an s and an s. And I'm left with, oh gosh, 2s plus 2h over sh, or 2s plus 4h over sh. That is my ratio of surface area to volume on the old. Now the new, s over v is 2s squared plus 8sh over 2s squared h. If I factor out the numerator, I can take out a 2s, and I'm left with s plus 4h over 2 times s times s times h. Okay, cancel out the things that are common. I can cancel out the 2 and the s. And I'm left with s plus 4h over sh. Now, the instructions said to find the surface area and volume, check. Calculate the ratio, check. Which of the ratios tell you about the efficiencies of the two tins? So the old tin, I had S over V of 2S plus 4H over SH. My ratio was S plus 4H over SH. So what do the ratios tell us here? It actually says that the old surface area to volume ratio is greater than the new surface area to volume ratio. And we can say it's bigger mainly because of this. Right there, my S is doubled. Everything else is constant. Okay, so right here we have the left side has a greater numerator than the right side. Okay, the denominator is equal. Okay, the only difference is the numerator is greater. Okay, so the old tin is less efficient. Which is quite interesting. Okay, let's practice a few. Simplify the expression if possible. So you're looking for things in the numerator and the denominator that are the same that you can cancel out. So we have an answer of 2 over x plus 3. Okay, I didn't have to factor anything in number 1. Number 2, I need to factor out a common number in the numerator, which would be 20, 2x plus 1, and 10, x plus 3. Okay, I can cancel these, and I get 2x, oh, that's hard to read, sorry. 2x, 2x plus 1 and x plus 3. Okay, I can leave it like that, or I could say 4x plus 2 over x plus 3. Both are equal. Okay, factor the expression if possible. I can't do anything with that one. so it's in its most simple form. There's nothing to factor and cancel out. Here, the numerator, can't do anything with. Denominator, I have difference of two squares. Remember, it's a plus b, a minus b. So I can do x plus 4, x minus 4, cancel out the numerator and the denominator. I have 1 over x minus 4. And this right here is the clue. I know I have that in the numerator, so the denominator needs to have one of those, or it's not going to be a problem that we can solve in Algebra 2. Okay. If I look at number 5, I have two things that multiply to negative 3 and add to negative 2. So the only thing that's multiplies to negative 3 is 1 times 3, and to add to negative 2, I get 1 plus a negative 3. So 1, x plus 1, and x minus 3 in the numerator. Two things that multiply to negative 6 and add to negative 1. 2 times 3 is negative 6. If that is negative and I add them, I get a negative 1. X plus 2, x minus 3. And we're almost always going to have things that cancel out. So my answer is x plus 1 and x plus 2. Simplify the expression if possible. Okay, factor out what we can in the numerator. I see a 2x that can be factored out. So I get x plus 5 left over. Two things that multiply to 15 and add to 16. I think 1 times 15 is it. This is where we have to factor by grouping. So 3x squared plus 1x plus 15x plus 16. Nope. Sorry. I take this and I separate it into 1 and 15. So we go there. I group the first two and the last two, and I factor out the common factor. I'm going to rewrite the numerator first. The denominator. So here I can factor out an x. 3x plus 1 is left. Here I can factor out a 5, x plus 1, rewrite the numerator, and I get x plus 5, 3x plus 1. Hold on, I see a mistake right there. Sorry. That cancels. I'm left with 2x over 3x plus 1. Okay, what if? In example 2, suppose new popcorn tin is the same height as the old tin, but has a base with twice as long. What's the ratio of the surface area to the volume of this tin? Surface area to volume. So we're just doing the new popcorn. The base is the sides are twice as long. So we're drawing this. So we have 2s and 2s and h. So the surface area is the area of the base, 2 times the area of the base, which is 2s times 2s, plus 4 times the area of the sides. I didn't draw that one, sorry. 4 times 2s times h over volume, which is 2s times 2s times h. Okay, let's do some work here. This is going to be 2 times 4s squared, or 8s squared. Here I have 4 times 2sh, or 8sh, over 4s squared h. Okay, let's factor out the numerator. I have 8s, s plus h, over 4s, sh. Okay, this cancels. I get a 2 left over. So 2s plus h over sh, which is correct. Or I can say 2s plus 2h over sh. Either one of those is perfect. Phew. All right, moving on before example 3. So now we're going to multiply rational expressions. The rule for multiplying rational expressions is the same as the rule for multiplying numerical fractions. You multiply across the numerator, and then you multiply across the denominator, and write a new fraction in simplified form. So here I have A, B, C, and D. Their expressions, B can't be 0 and D can't be 0 because I've got A over B times C over D. Numerators can't be 0. I just multiply across the top and get AC, multiply across the bottom, BD. And then I have to simplify if possible. Our example, 5x squared over 2xy squared, 6xy cubed over 10y. Multiply across the top, I get 5 times 6 is 30. X squared and x is x cubed and y cubed. 2 times 10 is 20. X times nothing is x. Y squared and y is y cubed. Okay, so we did all the multiplication. Now we have to simplify if possible. I have this right here. Okay, factor it. Times 3, x squared, y cubed. Okay, 20 is 10 times 2, x, y cubed. So cancel out the things that are common and write down what's left over. So I have a 3x squared and a 2, and that's my answer. All right, multiply across the top and across the bottom. 8 times 7 is 56. X cubed, x to the 4th is x to the 7th. Y and y cubed is y to the 4th. Over 2 times 4 is 8. There's only one x. There's 3 y's. Okay, factor if possible. So I know I have an 8 times 7 times x to the 6th times y cubed. Okay, I split those into things that I saw in the numerator. I have an 8, an x, and a y cubed. So I know I can cancel things. And I know I can circle things that are left over. So my answer is 7x to the 6th y, which is B. Okay, this is a little messier. Okay, I would not recommend multiplying across and then simplifying. I would actually recommend simplifying first, canceling, and then multiplying. So I've got this problem right here, this part of the problem, I'm going to factor it. 3x, I'm left with 1 minus x. That denominator factors into x minus 1, x plus 5. Here, this numerator factors into x plus 5, x minus 4, and a 3x. Now I cancel the things that are common. We can cancel this way, and up, down. So I can cancel up, down, left, right. Oops, that doesn't cancel. 1 minus x is correct. These cancel. Cool. Now, this one right here is actually quite important. I'm going to circle it in blue. I want those to change orders, and I can do that by factoring out a -1. Okay, if I multiply this back, I get -x plus 1, which is what's right up here. It's a trick. But now I can cancel this, and I'm left with -1 times x minus 4, or -x plus 4, right? Which is correct, or 4 minus x, which is also correct. Okay, this part right here is a trick that you need to know. Okay, I want these to switch order, so I factor out a -1 and I flip these orders. Okay, again here, this is over 1. I don't want to multiply through yet. I want to simplify first. So x plus 2, This right here is a difference of cubes. We did this as a warm-up. X minus 3, x squared plus 3x plus 9 times, factor this. Can I? I need two things that multiply to 9 and add to 3. I don't see anything that does that. So we're going to leave that go and just write our problem. Ooh, luckily this is on the denominator, that's the numerator. Now I can multiply across the top and the bottom. X plus 2 over x minus 3 is in fact my final answer. All right, we're going to do these guided practice and then be done for the moment. You can multiply across the top and the bottom first. I get 18x to the 6th, y to the 4th over 8 times 9 is 72, x to the 4th, y squared. Then I can factor 9 times 2. Looks like we want an x squared, x to the 4th, and y squared, because that matches up the bottom. 8 times 9, x to the 4th, y squared. Now I can cancel things out. A 9, x to the 4th, y squared. And I circle what's left over. A 2, an x squared, a y squared, and an 8. Ooh. That means I can go no 2 to a 4. So my numerator is x squared over 4. Y squared. I almost forgot the y squared. Cool. All right, this one's a little more complicated, so we're going to factor things out. In the numerator, I can take out a 2x. I'm left with x minus 5. Denominator, x plus 5, x minus 5. Okay, times numerator, x plus 3, can't do much with. 2 times x times x. Can take out the 2x, x minus 5, x minus 5. So I'm left with x plus 3 in the numerator, and x times x plus 5 in the denominator, which is cool, or you can say this. And 10. Okay, I put that over 1 just so it looks better. Here's the difference of perfect cubes. That gives me x minus 1, x squared plus x plus 1 times, can't do much with that, but I know I can do this now, which is cool. X plus 5 over x minus 1. Okay, we are going to stop there because that's a lot of new information in one day. Okay, a stop sign is 1, 2, 3, 4, 5, 6, 7, 8, an octagon. And we'll begin again tomorrow. Okay, I'll fix Classroom for you.